In this lesson, we will talk about the northwest corner rule. Here we have an optimization problem in which we want to ship our supplies from 3 different factories to 3 different warehouses. Each one of our factories have a supply capacity as shown in the right-hand column, whereas each one of our warehouse has a demand factor shown here. And the demand for warehouse C is 200. Okay, the key thing to understand is that in order to do this problem, we must have a situation where supply is equal to demand. In this case, we have supply is equal to demand. And we are going to try to find an initial optimal feasible solution using the northwest corner rule. So in order to start with the northwest corner rule, of course, we will start in the northwest corner, which is here. And in starting, we will look to see what our capacity is and what our demand is. And in this column, we will look to find the optimal. In this case, this is a minimization problem. We want to minimize cost. So the minimum cost in this column would be $5. So, but what's our constraint? We're constrained by our factory capacity or our supply capacity of 100. So we can only supply 100 at $5. So when we do that, we will supply 100 at $5, which will max out our capacity here, leaving us with 0 in this case from factory A, leaving us with 0, but also our warehouse requirements in this case would be reduced by 100, which will make that 200. Okay, so basically we have maxed out the capacity at factory X. So we're going to slide a little X beside that, indicating that we can't use that row anymore. So continuing with our method, we now look at the remainder of the first column, and we would see which is our optimal. Well, in this case, 8 is less than 9, and since we're minimizing, we're going to use 8. So what can happen at 8? Well, we see that factory Y can supply 300, but the requirement on the warehouse is only 200. So we can only ship 200 to the warehouse. And in this case, we can ship 200 to the warehouse. And if we ship 200 to the warehouse, that eliminates our requirement for that particular warehouse. And so now this column we're finished with warehouse A. So as you can see, we're now finished with factory X and warehouse A. So now we continue with the northwest corner. We want to look at this column, realizing that this row and this column have been eliminated. So now we see that we have eliminated warehouse A, but we have 200 here. Factory Y is delivering 200 to warehouse A. So if they deliver 200 of their factory capacity of 300, what is remaining of my factory capacity now is 100. So I reduce the factory capacity down to 100 based on what I've already done. Now we are ready to go to the next column. In the next column, when I optimize between what's left, 4 and 7, I see that 4 is less than 7, therefore 4 is the minimum number, and I see that I can do 100 is what factory Y can now supply, but warehouse B demands 200. So I can only supply what I have, so I'm going to supply 100 to warehouse B. And once I supply 100 to warehouse B, then I'm going to eliminate 100 here and take this down to 0. Take this one to 0. And thus I eliminate this row. And because I've used up, I'm able to ship 100, this takes the demand here down to 100. It takes the demand to 100. The demand goes to 100, and I still have some left over. So given that I have some left over, I'm going to look here at $7, and I see that factory capacity is 300, but warehouse B, the demand is only 100. So now I'm going to ship 100 to warehouse B. And when I ship 100 to warehouse B, I eliminate that requirement. That takes that down to 0. Takes that down to 0. And that eliminates that column. Now that I have eliminated, I have 100 here and eliminated the supply, the demand here, I'm going to have to adjust my supply, and my supply adjusts down to 200. And so now I'm ready to head to the last cell, because I have eliminated warehouse A, warehouse B, factory X, factory Y, and so the only thing left for me to do now is to ship 200 to warehouse C and factory Z. And when I ship 200, I'm going to eliminate this 200, and I'm going to eliminate that 200, and now I will have 0 here and 0 here, which will tell me now I have an initial feasible solution, and my initial feasible solution is I'm going to take 100 times 5 plus 200 times 8 plus 100 times 4 plus 100 times 7 plus 200 times 5. And when I do that, I'm going to get 500 plus 1600 plus 400 plus 700 plus 1000 equals $4,200. Thus, $4,200 becomes my initial feasible solution. Now, the question is this solution optimal? Well, that would be what we will look at in our next discussion.